Hi, I'm Tina from Prep 101. In this video, I'm going to teach you about log equations, log rules, and eventually we'll be finding the derivative of log functions. The logs will be used throughout this course. Okay, let's get started.
So the first thing we're going to talk about here are our log rules. So there are 3 log rules that you hopefully still have memorized from high school. So the first one is, if you're adding 2 logs with the same base, 2 logs separately being added come into 1 log by multiplying. So if I gave you, let's say, log 2, 3 plus log 2, 4, they're both base 2 here. And we could say that's log 2 and then multiply 3 times 4. So that's an example of the first log rule. The second log rule says 2 logs separately being subtracted come into 1 log by division, by dividing them. And of course, if there's no base here, it's base 10, but we can make it any base. And as long as they're the same base and they're being subtracted, then they can come into 1 log by dividing. Okay, so this is something like log 2, 9 plus log 2, 3 is log 2 of 9 divided by 3. And we'll talk about how to evaluate the logs very soon. And the last one is the power rule here, that if we have log base 10 here, a to the C can come out in front. So we use that throughout the course in many instances. When we get to logarithmic differentiation, when we get to L'Hopital's rule, we'll use that log rule quite a bit. So this would be, for example, log 2, 2 to the 4. The 4 comes down in front, 4 log 2, 2. So those are the first, those are the 3 log rules that you have to remember. There's also a few properties that you can learn just in case they come up throughout the course. So I'll remind you of those just in case as well. So the first property is that if you have e to the ln of x, the answer is x. So if we have e to the ln 3, ln is base e, that's log base e, that's the same thing as ln, that's what ln means, log base e. So the e's match, so the answer is 3. If we have log x, x to the a, the answer is a. So if we have log 2, 2 to the 3, the answer is 3. Why is the answer 3? Well, if we bring the 3 out in front here, then we get 3 log 2, 2. And if we evaluate this, we ask ourselves, little base number, 2 to the what number is 2? Well, 2 to what exponent is 2? The answer is 1. And so we get 3 times 1, which is 3. So you can memorize if you like, rather than going through all these steps, that if you have the base and the number here, if they both match, then the answer on the exponent, the 3 would just be your final answer. So log 2, 2 to the 3 is 3. It works the same way if it's a to the log base a of y. So here, if we had 2 to the log 2 of 4, this would just be 4. Well, how come? Well, let's evaluate this. 2 to the what is 4. 2 to the 2 is 4. And then we have 2 squared, which is 4. So again, a to the log a of y is just the y. So if we had 3 to the log 3 of 8, what would our answer be here? 3 and 3, they match. The answer would be 8 using that property. And one more property, ln e to the w is w. So ln e to the 3 would just be 3, because if our 3 can come down in front from our log rules, then we have ln of e. And you have to memorize that ln of e is 1. So this would be 3 times 1 is 3. So if we had ln e to the 5, the answer would just be 5. And the last 2 are just 2 things that you have to memorize because you're not allowed to calculate in this course. So the ln graph, 2 points that you should know in the ln graph are ln of e is 1 and ln of 1 is 0, because those will come up throughout the course. Okay, to put something into exponential form, what do? They give you a log equation and they say solve it. So let's say I have log 5, 25 equals x. So equals some unknown. How do I solve this? I solve this by putting it into exponential form. Exponential form is take the base, the little base, so 5 to the what's over here, to the x, equals 25. Okay? So always start with a little base, 5 to the x equals 25. And then you have to think 5 times 5 times 5, how many times gives us 25? Well, 5 squared, so x would be 2. So always keep that in mind. Exponential form is used anytime you want to solve a log equation. You use your log rules first, and then once you've used your log rules to get it down to 1 log, then you're always going to use exponential form. So keep that in mind. Okay, so here's an example of a log equation to solve. It could be on your exam. So log 4 x plus 1 plus log 4 x minus 2 is equal to 1. So we have two log 4s, two separate logs being added. So what's our log rule here? Well, two logs being added at the same base can come into 1 log by multiplying. So we take x plus 1 times x minus 2 inside that log. So log 4 x plus 1 times x minus 2 still equals to 1 on the right. Now we have it down to 1 log. That was our log rules. So remember what we said. Once you get it down to 1 log, you're going to put it into exponential form, we call it. So write down, what do you think the exponential form would be here? So little base 4 to the number over here is 1 equals x plus 1 times x minus 2. Now you can't solve this. It has to be equal to 0 before you start solving it. So leave this as 4, FOIL this out. First, x times x is x squared. Outside, x times negative 2 is negative 2x. Inside, 1 times x is x. And last, 1 times negative 2 is negative 2. And if we bring it all to one side, we have x squared, negative 2x plus x is negative 1x. And bring the 4 over with the negative 2 and we get negative 6. And now you've got a trinomial, so you've got a factor. So you've got to find two numbers that add to your middle term, which is negative 1, and the same two numbers multiply to your last term, which is negative 6. And numbers that will add up to negative 1 and multiply to negative 6 are negative 3 and 2. So in brackets, we have x negative 3 and x plus 2. So keep in mind, your answers aren't negative 3 and 2. If x minus 3 equals 0, then x is 3. And if x plus 2 equals 0, then x is negative 2. Now remember, you always have to check for log equations, okay? They're not like exponentials where every answer you get works. So always check your answers. Okay, so keep that in mind. So what we want to do is we want to look back at the original equation and make sure that these don't make the log 0 or negative, because we know we have to take the log, anything we take the log of has to be above 0, right? Looking at our log graphs, remember your log x graph or your ln graph, we don't have anything over here on our log graph, right? So we know that to take the ln of x, x has to be positive. So look at the number 3. That was our first answer. If we put 3 into here, we get log base 4, 3 plus 1. That's log of 4. That's fine. And then 3 minus 2 is 1. Log of 1 is fine. So that answer works. If we put negative 2 in, we get negative 2 plus 1. Negative 2 plus 1 is going to be a negative. And if it makes either of them negative, then it's not a solution. It's inadmissible. So our only solution on the exam would be, therefore, just x is 3. Now, most of the time, if you get 2 answers, one of them doesn't actually work. So be careful and don't fall for that on the exam. Okay, if we've got an exponential equation, solve for t. E to the 2t equals 8. E to the 2t equals 8. Okay, so what do we do? Since we don't have a calculator, then we can't say, 8 is e to the whatever. We can't do that in our head. It's too tricky, right? So we take the ln of both sides. So ln e to the 2t equals ln 8. And why does taking the ln help us, right? Why does it help us to say ln e to the 2t equals ln 8? Well, now we can bring our exponent down in front. So we have 2t ln e equals ln 8. And ln of e, we've memorized, is 1. So we have 2t is ln 8. And we can just divide both sides by 2 here. And so t is ln 8 over 2. Please keep in mind, ln 8 over 2 is not the same as ln 4. You can't divide inside a ln like that. The one thing they might do to you is break down 8 as 2 to the 3. And so they might bring the 3 down in front and say 3 ln 2 over 2. That's a possibility. But ln 8 over 2 is also another possibility for the exam. So it just depends on who's writing it and what they decide to do in this particular year. Okay, there's a change of base formula that you need to know. There's actually 2 of them that we talk about in this course. So the first one you can write down right here. Log base A of x is log bx over log ba. So when we go to evaluate log base A of x, we say it's log x over log a. But we can change that base to anything we want. Okay, so we'll talk about that. The other one is fairly common where they give you something log ax and you don't like to evaluate it that way, so you switch it and do 1 over log xa. This one, for example, if I have log 9, 3, I don't like to think in my head 9 to the what is 3. That's tricky. So I would rather say, oh, that's 1 over log 3, 9. And I can it's much easier in my head to say, 3 to the what is 9, right? 3 to the 2 is 9. So that's just much simpler for a lot of people. So that's one of the log rules. This one here we're going to talk about in detail in the next example. So we want to simplify log 2, 3 plus log 2, 27 all over log 2, 27. So the first thing we do is we have two logs separately being added. So two logs separately being added, we use our log rules, and two logs separately being added can come into one log by multiplying. So we have log 2, 3 plus log 2, 27 becomes log 2, 3 times 27 over log 2, 27. So we multiply 3 times 27, so we get log 2, 81 over log 2, 27. And remember, our log rule says that if we have a fraction of logs and they're both the same base, we can switch that base to anything we want as long as we switch them both to the same thing, right? So if we have both 2's, then we can switch them both to 4's, or we can switch them both to 5's. If we had log 2 over log 3, then we wouldn't be able to use the change of base. It has to be the same base on the top and bottom. So 2 to the what is 81, I can't do that in my head. And 2 to the what is 27. I can't do 2 times 2 times 2 and get 27. I have no idea what the strange decimal that would be there to make it work. So, but I do know 3 to the what is 81 and 3 to the what is 27. So I switch them both to base 3. So log 3, 81. 3 to the what is 81? Well, 3 times 3 times 3 times 3, 4 times gives me 81. And 3 times 3 times 3, 3 times gives me 27. And so that would be my answer. So that's called the change of base formula. So here's one off of an exam. So something similar to this was given. So hit pause and see if you can work it out using your change of base. So we have log 2, 3 plus log 2, 81. So same base, so we bring them into one log by multiplying. So log 2, 3 times 81. And then here, 3 times 81 here would be 243. And so now we've got to say, well, 2 times 2 times 2 to give us 243 is too hard. Same with 2 times 2 to give us 81, some strange decimal, so we can switch them both to 3's. And 3 times 3 times 3, 4 times gives us 81, and 3 to the 5 gives us 243. Okay, example 5. Evaluate log 25 of 125 plus log 6, 36 plus log 4, 8. So if we write out the definition here, this would be log 125 over log 25. This would be log 36 over log 6. And this would be log 8 over log 4. So if you were graphing back in high school, then to type this in, to get the decimal, you would just type on your calculator log 8 divided by log 4. And those will be both using base 10. But now that we've got the definitions of them written out, we've got to say, well, what could we deal with to deal with 125 and 25? What kind of base would work? 10's not going to work. 10 times 10 is 100. That's not going to give us 25 or 125. But if we switch them both to 5's, we get log 5, 125 over log 5, 25. And that's going to work. We can do 5 times 5 times 5 to get 125. So what would you do for the 36 and the 6? And what would you do for the 8 and the 4 here? hit pause and fill in what you think. So here I would use 6 on the top and bottom. And the last one I would use base 2. Sometimes people think base 4, but remember 4 times 4 is 16. So we're not going to get the 8 out of that. So we have to be careful with that one. So 5 times 5 times 5, 3 times is 125. 5 times 5 twice is 25. 6 times 6 twice is 36. And 6 to the what is 6 is just 1. 2 to what exponent is 8? 2 to the 3 is 8. And 2 to what is 4 is 2. So if we take these, we've got 3 over 2 plus 3 over 2. So that would be 6 over 2. And 6 divided by 2 is 3. So we end up in the end with 3 plus 2 is 5. And that's our answer. Okay, I'm going to show you one more, which is an equation to solve. A little bit trickier, something that was off a recent exam. So log 3x plus log 3x plus 2 equals log 3x plus 20. So I want you to hit pause and I want you to work that out and go as far as you can. Okay, so on the left we have 2 logs base 3. 2 logs separately being added can come into 1 log by multiplying. So we take x times x plus 2. The left is done there, and we just copy down the right and just leave it for a minute. So then we can multiply this out. X times x plus 2 would be x squared plus 2x. And we haven't seen this style before, but if we have log base 3 of something and log base 3 of something else, and they're equal, then since the log base 3's are equal, we can say that x squared plus 2x is equal to x plus 20. And that's how we solve it. And so we bring everything to the left. We get x squared plus x minus 20. And again, we're looking at a trinomial, so we want to add up to the 1 in the middle and multiply to the negative 20. So 2 numbers that are 1 apart that multiply to negative 20. And so here we would have 5 plus negative 4 would be 1, and 5 times negative 4 would be negative 20. And keep in mind, x plus 5 equals 0, so x is negative 5. And x minus 4 is 0, so x is 4. And we have to check to make sure neither of them make the log up top in the original question. They can't make any of the logs equal to 0 or a negative. It has to be greater than 0 for all our logs. So negative 5, well, that will make this one log 3 of negative 5, and that's impossible. So negative 5 is out. As soon as you find one that makes it out, you're done. It has to work in all 3 for it to be a solution. So 4, log 3, 4, that's okay. Log 3, 4 plus 2 would be log 3, 6. That's okay, 6 is above 0. And log 3, 6 plus 20 is log 3, 26, and 26 is above 0. So our final answer would be therefore x equals just 4.
I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.